What is thermodynamics? Thermodynamics is a branch of physics that deals with the relationship between heat, energy, work, and matter. It studies how energy is transferred and transformed, particularly in systems involving physical and chemical processes. The field is governed by four fundamental laws, which is the zeroth law, first law, second law, as well as the third law. The zeroth law establishes the concept of temperature and thermal equilibrium. The first law states that energy cannot be created or destroyed. It is based on the principle of conservation of energy, where energy can only be transformed from one form to another. The second law states that the direction of energy transfer and introduces the concept of entropy, stating that the systems naturally progress toward greater disorder. Finally, the third law asserts that as the temperature of a system approaches absolute zero, its entropy approaches a minimum. Thermodynamics is the fundamental to the functioning of refrigeration and air conditioning system, which helps maintain comfortable indoor environment and preserve perishable items. These systems rely on thermodynamic processes like compression, condensation, and evaporation to transfer heat from one location to another. In a refrigerator, the compressor compresses a refrigerant gas, raising its temperature and pressure. The heated gas then passes through the condenser coils where it releases heat to the surrounding air and condenses into a liquid. This liquid refrigerant moves through an expansion valve where it transitions into a low pressure gas, absorbing heat from the refrigerator's interior and keeping it cool. This is why refrigeration is one of the applications for thermodynamics in the industry.
The first law of thermodynamics, also known as the law of energy conservation, dictates that energy cannot be created or destroyed. In a closed system, the first law can be summarized in the form of the energy balance by considering the energy transfer in and out of the system. The first principle must also be met by the refrigeration process. Energy must be conserved during the refrigeration process according to the first law of thermodynamics. In this process, heat is moved from the colder to the warmer area. The refrigerant which absorbs rejects the heat must return to initial state where its internal energy is the same, since refrigeration is a cyclic process. Therefore, in order to satisfy the first law of the thermodynamics, the heat released from the refrigerator to the warmer environment must equal to the heat absorbed from the cabin air plus the work input by the compressor. What is heat engine? A general definition of a heat engine is the cyclic device that takes a working substance through a clockwise thermodynamic cycle, receiving energy in from the range of the high temperature reservoir, delivering positive work energy to an external load of the remaining energy. What is the refrigerator? A general definition of the refrigerator is a cyclic device that takes a working substance through a counterclockwise thermodynamic cycle, receiving the positive external work energy and heat energy from a range of low temperatures. When the first rule of the thermodynamics is applied to a single clockwise cycle, efficiency tests show that work done is equals to the heat energy in minus heat energy out is higher than the value 0. Similarly, a refrigerator cycle proposes to remove energy from a lower temperature region, and it is common to define coefficient of performance temperature for such a counterclockwise cycles. The general efficiency measures and temperature exist for any clockwise and counterclockwise cycles, but are of most of the practical interest for traditional model heat engines or refrigerators defined above as the equation shown. I use the Kelvin, Carnot, and Stirling cycles to illustrate some implications of reversibility and irreversibility for clockwise and counterclockwise cycles for the above equations.
The second law explains irreversible processes in nature and is based on experimental observation by scientists, which are from Clausius and Calvin Klein. Based on Clausius, it is impossible to transfer heat from colder object to a hot one without the assist of the external work. Moving on, based on the Calvin Klein, he contributed statements where it is impossible for the system to operate in a thermodynamic cycle and release the tissue to the surrounding heat energy. In refrigerator system, there are cooling machine installation process, which is compressor draws low temperature, low pressure refrigerant gas from the evaporator and compressed into hot gas, then transferred to the condenser where it is cooled by surrounding air. Next, refrigerant evaporation. In the evaporator, the refrigerant has a low boiling point and absorb heat, evaporating into a gas. And this heat absorptions help cool the contents of the refrigerator. And lastly, for the defrosting, An electric heater is used to defrost the evaporator by applying heat. Moving on, there are 4 types of thermodynamic process involved in refrigerator system, which is first, isobaric process. Heat energy is transferred to the refrigerator, specifically to a cooler area of the refrigerator. Next, isocurrent process, where the pressure will produce a volume of each hot and cold energy. Furthermore, for the isothermal process, where it causes energy changes in the electronic device system, where the heat energy will always lead to the cooler area, resulting in the transfer of heat energy into cold energy. And lastly, in adiabatic process, this insulation process does not introduce or remove heat from the system, but it changes the pressure and volume of the energy in the refrigerator by converting heat energy into cold energy.
In conclusion, thermodynamics is fundamental to the operation of refrigeration system, guiding the transfer and transformation of energy through processes like compression, condensation, and evaporation. The first law of thermodynamics ensures energy conservation during the refrigeration cycle, where heat is absorbed from the refrigerated space and released to the surrounding by the refrigerant. Meanwhile, the second law dictates the direction of heat transfer, explaining why external work is necessary to move heat from a colder to a warmer space. This principle governs the functioning of various components, including compressor, condenser, and expansion valve, which together facilitate the cooling process. By applying thermodynamics processes such as isobaric, isocurrent, isothermal, and adiabatic process, refrigeration systems are able to efficiently manage temperature and energy flow. While rail systems deviate from the idealized Carnot cycle, understanding these fundamental thermodynamics principles allow for improved design and performance refrigeration system. Ultimately, thermodynamics not only ensures that refrigeration systems work effectively, but also promotes energy efficiency and sustainability in modern cooling technologies.